This is Mrs. Appiah with Lesson 2, Linear and Nonlinear Expressions in X. Student outcomes for this lesson. Students know the properties of linear and nonlinear expressions in X. Students transcribe and identify expressions as linear or nonlinear. Remember when we graphed equations, we made a table of XY values, we graphed the points, and we connected the points. In Lesson 2, we will be answering the essential question, what distinguishes a linear from a nonlinear expression? Just to refresh your memory, terms are any product of an integer power of x and a constant, or just a constant. Constants are fixed numbers. When a term is the product of a constant and a power of x, the constant is called the coefficient. Reviewing what an expression is. There is no equal sign. Each term is either a constant or a product of a constant and x. Terms are separated by a plus or a minus sign. Here are three expressions. This is a constant. This is a variable, separated by a minus sign. This term is 2 times x. 2 is the coefficient. X is a variable and 7 is a constant. And we have 1/2 x plus 3 squared. An equation. An equation has an equal sign. An expression does not. An equal sign divides the equation into two parts, the left and the right. The two sides are expressions, or can be just one term. You've been given a piece of paper with several different expressions on it. Cut that paper into the 9 parts. Sort them into 2 groups, and be prepared to explain what is the difference about the 2 groups. There's a website that might help you distinguish what kind of equations they are. So click on this site and click Start Graphing. I'm going to enter the first expression, 5x plus 3. 5x plus 3. And if we graphed that expression, this is what it would look like. I'm going to go down to the second line and enter the second expression, 4x squared minus 9. 4x to the second power minus 9. Do you see what that looks like? That's the blue line. I'm going to click on the 3 and enter the third expression. It would be a good idea to sketch what each graph looks like on the piece of paper. So we saw that 5x plus 3 gave us this red line, and then this second expression gave us this blue parabola. And the next one we'll enter is the quantity x divided by 2 raised to the third power plus 1. For this one, we will need parentheses, and then we have x divided by 2. Close your parentheses, and then we want to raise that to the third power, so we'll use a to the b power, and then tell it what power you want, 3. Then I'm going to click over here, and next we're going to add 1. This is what our equation, or this is what our expression would graph as. On your little piece of paper, draw that description. Now, this is getting a little complicated on your graph paper, so if you would like to, you can delete those and just do one expression at a time to see what the graph would look like. So pause the video and enter each expression and write down what the graph looks like. Then you're going to place those or sort those papers into two groups and then explain why you chose that grouping. Pause the video to complete this exercise. I've separated my expressions into two groups. On this side, I have 5x plus 3, negative 8x plus 7 ninths minus 3, 0.31x plus 7 minus 4.2x, 11 times the quantity x plus 2, and negative 6 times the quantity 6 minus x plus 15 minus 9x. On the right side, I have 9 minus x squared, 4x squared minus 9. The quantity x divided by 2 raised to the third power plus 1, and 7 plus x to the negative fourth power plus 3x. The way that I have organized my expressions is into linear and nonlinear expressions. Notice the power of x. The power of x in all of these equations is 1. Remember the invisible 1. And on the right side, the power of x is other than 1. For example, it's 2, 3, or negative. And actually it's other than 0 or 1, because remember, anything raised to the 0 power is 1. So how can we distinguish between linear and nonlinear equations? For a linear equation, the power of x is 0 or 1, and that expression will result in a straight line on your graph. For a nonlinear expression or equation, the variable x has a power that is not 0 or 1. In example 1, a linear expression in x is an expression where each term is either a constant or a product of a constant and x. For example, the expression the quantity 57 minus x is a linear expression. However, the expression 2x squared plus 9x plus 5 is not a linear expression. Why is it not a linear expression in x? If we take a look at this term, 2x squared, notice that it has an exponent on the variable that is other than 0 or 1. Pause the video and copy that down. Example 2. Let's examine the expression 4 plus 3x to the fifth more deeply. To begin with, we want to identify the terms of the expression. When you identify the terms, remember that they are separated by a plus or a minus sign. So if we take a look at 4 plus 3x to the fifth, here is a plus sign. That makes this a term on the left and 3x to the fifth a term on the right. And so we have two terms. Then take a look at the variable and the exponent. We have a variable x, and it has an exponent of 5. Since the exponent is other than 0 or 1, this is non-linear. The exponent has a variable other than 0 or 1. Example 3. How many terms does the expression 7x plus 9 plus 6 plus 3x have? As it is, there are 4 terms. 1, 2, 3, 4. However, we can simplify this expression. as it is, it has 4 terms. If we simplify this expression and we combine our like terms, that would give us 10x, and 9 plus 6 is 15. In this case, there are 2 terms, and they are 10x and 15. Is 10x plus 15 a linear or a nonlinear expression in x? Why or why not? Take a look at the term that has the variable. If x had an exponent, it would be that invisible 1. Since it has an exponent of 0 or 1, it is linear. This is a linear expression. How do you know? The exponent is 0 or 1. It would be nonlinear if it was another different exponent other than 0 or 1. Example 4. How many terms does the expression 5 plus 9x times 7 plus 2x to the 9th have, and what are they? This is a tricky problem. Think about how terms are separated. Terms are separated by a plus or minus sign. And so this is technically one term. So we have 5, 9x times 7, and 2x to the 9th. So there are 3 terms. Is 5 plus 9x times 7 plus 2x to the 9th power a linear or a nonlinear expression in x? Why or why not? So let's simplify this, and that gives us 5 and then 63x and 2x to the 9th. So determining whether it's linear or nonlinear, you want to take a look at the variable x and its exponents. Well, we can see from this term that this will be a nonlinear equation. How do we know? The variable has an exponent other than 0 or 1. In example 5, 94 plus x plus 4x to the negative 6 minus 2. Is it linear or nonlinear expression in x? Why or why not? So what we want to do is we want to take a look at the term that has a variable and then look at the exponent. So this x has an exponent of 1. However, when you look at the other term, 4x to the negative 6th power, because this has an exponent other than 0 or 1, it is a nonlinear equation. Rather, it is a nonlinear expression. Example 6. Is the expression x to the first power plus 9x minus 4 a linear expression in x? Well, let's take a look at our terms. We have x and it has a power of 1. We also have 9x, and we don't look at 4. The constant does not determine whether it is linear or nonlinear. If x had an exponent, it would be 1. And if you think, well, what if I simplified that? If you simplified that, remember x plus 9x would equal 10x. So even in simplest form, this would be what kind of an equation? It would be a linear expression. How do you know? the variable has an exponent of 1. And remember, the 1, you don't see it. It's an invisible exponent. What powers of x are acceptable in the definition of a linear expression in x? Well, you can have x to the 0 power because that would equal 1, or you can have x to the first power. So 1 and 0 are acceptable exponents in a linear expression. On your own, write each of the following statements in exercises 1 through 12 as a mathematical expression. State whether or not the expression is linear or nonlinear. If it is nonlinear, explain why. Pause the video and complete problem 1, and then check your work. Sum means to add. We'll let x equal the number. 4 times the number would be 4x. The sum is to add those together. In simplest form, this would equal 5x. So this is our expression, and we know that this would be a linear expression because the variable has an exponent of invisible 1. Pause the video and complete problem 2. I'm going to let x equal the number. I know that the product means that I'm going to multiply. I'm going to multiply 5 and the number, and that would be 5x. Again, this is the same answer as the above, so you'll notice that this is a linear expression. It has an invisible exponent of 1. Pause the video and complete problem 3. I'm going to multiply by the reciprocal of the quotient of the number n7. So first, I'm going to write the quotient of the number n7. Quotient means division. The number and 7. The first item goes in the numerator, and I'm going to divide that by 7. So that is the quotient of a number n7. But I want to multiply by the reciprocal, and the reciprocal is 7 over x. So I want to multiply 6 times 7 over x. 6 times 7 over x. So this is my expression. Now be careful on this one because think about what your exponent would be. When x is your divisor, that would be x to the negative 1 power. So this can be rewritten as 6 times 7x to the negative 1 power. So would this be linear or nonlinear? This would actually be nonlinear because your exponent is other than 1. When you have a negative exponent, it will be a nonlinear expression. Pause the video and complete problem 4. Twice a number. How do you write twice a number? 2x. Subtracted from, so we're going to take that away from something. From what? 4 times a number. How do you write 4 times the number? 4x. Added to 15. So that would be 15, whoops, let's write it over here. That would be 15 plus 4x minus 2x. So this is our expression. You can simplify it if you'd like, and that would give us 15 plus 2x. So is it linear or nonlinear? Take a look at your variable x, and what would the exponent be? It is an invisible 1, so this would be a linear expression. It would result in a line on a graph. Pause the video and complete problem 5. We want the square, so that would be raised to the second power. The square of what? The square of a sum. So that would be adding two terms raised to the second power. What are the two terms? 6 and a number. So 6 and x. So we have 6 plus x raised to the second power. Now you want to be careful on this one. This is a tricky one. Notice that you do have an exponent of 2. So if you're thinking that it's nonlinear, you are correct. This can be simplified. 6 plus x raised to the second power means 6 plus x times itself, 6 plus x. We haven't learned how to multiply terms like this yet, but if we did, it would look like this. And we'll learn this later in the unit. We have 6 plus x multiplied by 6 plus x. So we have x times x, that's x squared, and then x times 6 is 6x. Next, we multiply by 6. 6 times x is 6x, and 6 times 6 is 36. Simplify, that gives us x squared, 12x, and 36. In simplest form, this expression results in 36 plus 12x plus x squared. And here you can see that this would be non-linear because the exponent on the variable is other than 0 or 1. Pause the video and complete problem 6. The cube of a positive number divided by the square of the same positive number. Let's let x equal the number. The cube of a positive number. Remember, the cube will have an exponent of 3. Divided by the square of the same positive number. And the square will have an exponent of 2. So we have the cube of a positive number divided by the square of the same positive number. In this form, you would expect a nonlinear expression because the exponent is other than 0 or 1. So in this form, this would be nonlinear. However, if you simplified that expression, that would result in x to the first power. And this would equal or would be a linear expression. So you always want to take a look at what it would look like in simplest form. Pause the video and complete problem 7. Okay. We have the sum, so we're going to be adding. We're going to add 4 consecutive numbers. Remember, our first number would be x. We'll let x equal the first number. The second number would be 1 more than that. The next number would be 2 more than x. And the fourth number would be 3 more than x. That is the sum of 4 consecutive numbers. Looking at it like this, it would look like a linear equation because all of the variables have an exponent invisible 1. If we simplified it and combined our like terms, we would have 4x plus 6. This is the expression in simplest form, and you would still see that it is linear because the variable is invisible 1. Pause the video and complete problem 8. 4 subtracted from. So we're going to be taking 4 away from something. From what? From the reciprocal of a number. Let's let x equal the number. If x equals the number, then the reciprocal would be 1 over x. So we have 4 subtracted from the reciprocal of a number. So that would be 1 over x minus 4. This is our expression. Now taking a look at the variable, you would think that the exponent would be a 1. However, remember that in the denominator, that would be a negative 1 if we simplified it. So 1 divided by x is actually equal to x to the negative 1 power minus 4. So this would be what kind of an equation? It would be nonlinear. How do you know? The exponent is other than 0 or 1. So it is a nonlinear expression. Pause the video and complete problem 9. Half of the product of a number. How do you do half of a product of a number multiplied by itself 3 times? Okay. First, how do you get half? You multiply by 1/2. Half of what? Half of a product. So you're going to be multiplying something. The product of what? A number. Let's let x equal the number. Multiplied by itself. Multiplied by itself 3 times. So x times x times x. Okay, so we have half of a product multiplied by itself 3 times. You could also write this as x times x times x divided by 2. Either one of those expressions would be fine. So looking at it in this way, you would think that it would be linear because of the invisible exponent 1. However, if you simplified the expression, it would be 1/2 times x to the 3rd power, or x to the 3rd power divided by 2. So this would be what kind of an expression? This is nonlinear. How do you know? It is nonlinear because it has an exponent other than 0 or 1. Pause the video and complete problem 10. The sum shows how many pages Maria read. If she read 45 pages of a book yesterday and 2/3 of the remaining pages today. Sum means that we're going to be adding. We're going to add the pages she read yesterday and today. Yesterday, she read 45 pages. Today, 2/3 of the remaining pages. Let's let x equal the remaining pages, and she read 2/3 of them. Remember that of means to multiply, so 2/3 of the remaining pages. So our expression is 45 plus 2/3 x. Is it linear or nonlinear? Look at the variable x. It does not have an exponent, but if it did, it would be an invisible 1. So this is a linear equation, or rather, this is a linear expression. Number 11, an admission fee of $10 plus an additional $2 per game. Pause the video and complete number 11. You'll be paying $10 plus an additional $2 per game. Well, how do you write $2 per game when you don't know how many games it is? That would be 2 times a variable for the number of games. We'll let x equal the number of games, and $2 per game would be written as 2x. So the admission fee would be $10 to get in plus $2 per game. This is our expression. What kind of an expression is it? It is linear. How do I know? The variable is an invisible one. Pause the video and complete number 12. 5 more than 4 times a number, and then twice that sum. First, how do you write 5 more than something? You're going to add 5. Add 5 to what? 4 times a number. Let's let x equal that number, and then 4 times the number would be 4x. And then we want twice that sum. Twice means to multiply by 2. So we'll have 2 times that sum. The sum of what? 5 more than 4 times the number. So we have twice the sum of 4x plus 5. Now determine whether it's linear or nonlinear. Looking at it, it looks linear because it has an invisible exponent of 1. You can simplify it to double check. Use the distributive property. That would give you 8x plus 10. And you see that it is a linear expression because it has an invisible exponent of 1 on the variable. We now have definitions for linear and nonlinear expressions. We know how to use the definitions to identify expressions as linear or nonlinear. We can write expressions that are linear and nonlinear. In this lesson, you've learned that linear expressions are sums of constants and products of constants and x raised to a power of 0 or 1. For example, 4 plus 3x is linear. 7x plus x minus 15 is linear. And you might be thinking, wait, that is a difference, not a sum. But remember that subtraction can be written as adding the opposite. So it can have a subtraction sign. And another example is 1/2 x plus 7 minus 2. These are all linear expressions in x because they have an exponent of 0 or 1. Nonlinear expressions are also sums of constants and products of constants and x raised to a power that is not 0 or 1. If it is not 0 or 1 on the exponent, it will result in a nonlinear graph. For example, 2x squared minus 9 because of the exponent 2 on the variable. Negative 6x to the negative third will be nonlinear because the exponent is a negative number. And 1 over x plus 8 will be nonlinear because if you simplified this expression, that would be 1 divided by x to the first. That would give you x to the negative 1 plus 8. So because this has a negative exponent, it would be a nonlinear expression.